We're going to start off this section with some definitions, okay? And they won't be anything too earth-shattering. So the first one says, a function f of x with domain D has an absolute maximum value at C if f of x is less than or equal to f of c for all x in D, the domain. So all this means is that we have an absolute maximum value at an x value c if the y value is the highest point, the absolute highest point for the whole graph. Okay, nothing gets bigger than it. And we don't ever include infinity here. We are talking about a finite value. Okay. Very similarly, we say a function f of x with the domain D has an absolute minimum value at c if f of x is bigger than or equal to f of c for all x in D. So this just means we have an absolute minimum if the y value at c is less than or equal to, smaller than all the other y values in the domain. Okay, so we're going to scroll down here for just a minute and look at this graph. Now, if we're talking about absolute maximums, this graph doesn't have one because over here to the left we're going up and we're assuming we're going up toward infinity. So it would never reach a maximum point. It would always keep going larger. So this graph would have no absolute maximum. However, another example, let's say we had maybe a parabola like this, and let's say that's up at 0, 5, we would say this parabola has an absolute max. And here we say the absolute maximum is the y value, so we'd say of 5 at x equals 0. So that we talked about is the x value where it happens, 0 here. Now this graph with absolute minimum, well, the lowest point this graph ever gets, since it levels off here, is this point right here. So this would be our absolute minimum. And let's just say this happens to be at -3. So this is the point for -3. And so what we'd say this graph has an absolute minimum of -3 of the y value at x equals 4. So the x value is kind of where it happens. Okay, now we have two other terms. So we say a function f of x with domain D has a local maximum, and here the word that's different is local. Okay, so before we talked about absolute, and sometimes with the word absolute for both of these, you'll also hear the word global. Just another term for the same thing. But here we're talking about local ones. And this just means if f of x is less than or equal to f of c for all x in D lying in some open interval containing c. And you can kind of think of this as being nearby C. So we call it a local maximum if nearby it's the highest point. So down here with our graph, these are going to be kind of the top of hill. So this would be a local maximum. So, you know, if let's say that's at 1 and let's say this is 4. So this is the point 1, 4. We'd say we have a local maximum of 4 at x equals 1. Okay, and local minimum is very similar. A function f of x with domain D has a local minimum at c if f of x is greater than or equal to f of c for all x in D in some open interval containing c. So again, that just means nearby c. Okay, so this graph has a couple local minimums. This point down here, so local minimums are kind of the bottom of a valley. So this would be a local minimum, let's say that's at -2, of -2 at x equals -5. And global or absolute minimums are also local minimums. Okay, so we can only have one absolute minimum or absolute maximum. We might not have any, but we can have multiple local mins or local maxes.